student at
Thank you. แล้วเอาลิงก์มาป่ะเอาลิงก์ที่ชื่อป่ะเอาไหมทันป่ะ
โอ้ไม่ทันตอนนี้
ไม่ถึงลิงก์เลย
แล้วลิงก์ที่ไหนล่ะ
อ๋อไม่ถึงลิงก์มันสร้างไว้ด้วยอ๋อไม่แล้วหนังอ๋ออันนี้คือสร้าง
ลิงก์นะ
not exercise
okay 6 students 4
ได้วิชทั้งระดับเนี่ยทั้งหมด
you can show your face
Yes.
when I start
ทั้งระดับจริงๆเนาะจริงๆแล้วก็4 ห้องอ๋อไฟวินเป็น4ไปเรื่อยๆเป็น
It's my view.
ไม่ได้เรื่อยๆทำไม4 ห้องนะ
มีห้องไหนครับ
น่าจะถูกห้องน่าจะถูกห้อง
สามพิเชอร์สองห้อง
มี5 ทั้ง 2 ทั้ง 3ใช่
เดือน
เพราะเป็นคอมพู
8 ห้อง
3 ห้อง
อ๋อคือพิเชอร์2 ห้องเขาบอกให้พิมพ์ชื่อเป็นภาษาอังกฤษก็ได้
นี่เขาขึ้น
อ๋ออีกก็อ่านไม่เข้าออก
2 ชื่อรูป8 ห้อง
เจอที่เราบอกในพอทุกคนในเวลาของเจอพอเราจะสอนเลยคนทั้งหมดเขาเรียกว่า
ต่าง
อาชิวเที่ยวต่อไปยิ้มยิ้มสองได้ไหมสองได้มาเลยเหรอได้เสียเปรียบที่มันอยู่ในสองวันนี้สองจะได้มันไม่ขายแบบมันจะเสียได้ที่ไม่ครบอย่าง
โดยห้องผมวันที่เป็นเลข
แค่นั้นแหละดีที่สุดเลยวันที่เป็นเลขอะไร
เต้ยไม่เอา
วันนี้ไม่มีอะไรกิน
เด็กๆพิมพ์ภาษาอังกฤษคุยกับมาสเตอร์นะครับคุยกับทีเชอร์นะครับ
ไม่มีหาใครไม่เห็น
แล้วก็กติกาการเช็คชื่อก็อยู่บนกระดานเลยนะครับบางคนที่เข้ามาแล้วยังไม่ได้เช็คชื่อเลยอย่าลืมเช็คชื่อด้วยนะครับแล้วก็ถ้าจะคุยในคลาสนี้มันเป็นคลาสไซแอนเนาะวิชาภาษาอังกฤษดังนั้นพิมพ์ภาษาอังกฤษมานะไม่ต้องพิมพ์ภาษาไทยแล้วก็ไม่ในคลาสนี้จะไม่มีการแซวทีเชอร์เนาะถ้ามาสเตอร์เห็นใครแซวมาสเตอร์จะเอาชื่อคนนั้นไปหักคะแนนเองสุดท้ายโอเคเต้ย
ต่อได้หอมสิโอเคนะ
4 minutes, then it starts. 4 minutes.
You can begin teaching.
Can I continue? Yes. I will until 10 minutes.
Yeah.
Free.
Say it again. Okay, start.
Okay, welcome everyone for today's class, online class, and hope you're keeping yourself safe from COVID, you and all your families. Now, again, as we begin, always remember to write your name, your room, and your class number in the comment section. I want us to continue from where we stopped last time. We had the topic force, but today I want us to look at motion. Now, we learned about motion in grade 9, that is Mathematics 3. Now, we are going to study this again because it is a foundation for what we are going to study next week. The subtopic is distance, displacement, speed, and acceleration. Next one, we have the following. Now, these are the keywords. Keyword number 1 will be motion. We're going to study what is motion. We'll define what is motion and look at the related words. 2, scalar quantity. 3, vector. 4, distance. 5, displacement. 6, speed. 7, velocity. 8, acceleration. 9, 9, distance time graph. This one should be next week. Followed by speed time graph. Also, this one should be next week. And then equations of motions, Newton's equations of motions. And then circular motion, projectile motion, simple harmonica. We look at this one. But for today I just want us to look at this. These keywords here: motion, scalar quantity, vector, distance, displacement, speed, velocity, and acceleration. I know we have learned about this before. I want us to go through these words again so that it can be a foundation or a background of what we are going to study next period. Now, we cannot study about the equations of motions if we have forgotten about all these words here. So here we go. We are going to look at motion. We have this kind of map here. We have the scalar quantities and the vector quantities. We are going to ask ourselves, what are scalar quantities? These are quantities that only have the magnitude, only give you the size, the magnitude. The vector quantities, they give you the magnitude, that is the size, and also the direction. Next one, we'll have what we call distance on the scalar side. For example, if you only have a number, a magnitude, for example, say distance is 4 kilometers. Displacement is a vector, gives you the number and also gives you the direction, 4 kilometers now. Then also related to this side and distance, we have what we call speed. Speed defined as distance divided by time and velocity displacement divided by time. Now, all this is what we are going to look at today. Then uniform motion, again, this we are going to look at it when we look at the graphs. And the changing one, we have the acceleration. Rate of change of velocity divided by time. The acceleration, we are going to split it into 3. We have what we call the circular motion, and also we have the projectile motion. The last one is the simple harmonic. This should be around period 3 or period 4 during the online session. Now, what is motion? Very quickly, motion is any movement that changes its position. Any movement that changes its initial position. When you move from one point to another, this is what we call motion. It can be described in 3 ways. One, in a straight line, moves in a straight line. Motion that moves in a straight line. or motion that changes its position in a circular path, moving around in a circular path, or motion that changes its position like a pendulum, right? To and fro. This animation is not so clear, but just to and fro is like a pendulum. So you describe motion as any movement that changes its initial position. Next, I want us to look at position. These were here positions. Position describes a measurement of a location with reference, or when you refer to the original point. When you refer to the original. For example, we have a school here. We have Jack, and we have the original position, which is O. And then we have Anne, and then we have Pack. Now, how can you describe position with relationship to one, distance, and also displacement? This is how you go about it. Now, again, our original position is this one, letter O. And then R is 100 meters from the origin, whereas R is on this right side, 100 meters from the origin. The origin is letter O. And then it's a positive number. Pack is again 300 meters. Why? From this point O is 100 plus 100 plus 100. When you combine those two using the subscript X to 300 meters. Then again, another example here is Jack. Jack on the left side. Jack on the left side is negative 100 meters from the origin. And the origin, why is it negative? Because it's on the left side, using the x-axis on the left side. So it's negative 300 meters from the origin. And the last example we have is the school. The school is 300 meters from the origin. Yes, from this point, the origin is letter O. When you add all this is 300, then negative 300 meters on the left side of the picture. Next one we have is distance and displacement. Again, we have these again in grade 9. This is just a foundation for what you're going to look at in the next subsequent lessons. Distance is the actual length of the path covered by a moving object. For example, if this object moves from point A to point B, A to C, C to D, D to B, this is what we are referring or we are calling to as the distance. But now, displacement is different from the distance. It describes the shortest distance between any given 2 points. Mostly it's a vector quantity. It's a straight line, a vector quantity. The shortest distance between 2 points, which is a vector. Now, scalar and a vector quantity. Here we go. Distance is a scalar quantity. Why? It has only the magnitude. Now, this word here, the magnitude, simply means the size. Gives you a number like 4 kilometers, 10 centimeters. Only gives you just a number. No direction sense. But displacement is a vector. A vector, why? Because it gives you 2 things. You need 2 things to describe displacement. One, you need the size, the magnitude, and also you need the direction. So anytime you describe displacement, you have to give those 2, the direction and also the size of the quantity. Next, we have, let's look at some examples. Let's look at this ant here. This ant here is moving from point 0 to point 4. From 0 to 4 centimeters here, a straight line. So the displacement in this case is the distance between the distance again is 4 centimeters. Because it goes from 0 to point number 4 centimeters, the distance is 4 centimeters. And the displacement is positive 4. From 0 to 4. Now, this positive number gives you the direction. Gives you the direction. Gives you the direction. Next one, we have another example is the same ant moving in opposite direction. Find the ant's displacement again. Moves from 4 to 0. Again, the distance is 4. the displacement is negative 4. Again, the negative shows you that direction. So displacement is a vector, gives you a number, and also gives you the direction. The next keyword we have is, let's do one example first. One example, find the distance and displacement if you travel 4 kilometers north and then 5 kilometers south. Find and calculate the distance and also calculate the displacement. The distance is 5 kilometers plus 5 kilometers. Again, this is easy, you get 10 kilometers. The displacement, again, is the shortest distance between points. Now, you started from your home, your residence, you went to school, and you came back. So there is no displacement. The displacement in this case is 0. There is no displacement. Why? The starting point is still the ending point. So there is no displacement. No displacement. Displacement is 0. Go to the next slide. Speed. Speed is described as how fast an object is moving. How fast an object is moving, we describe that as speed. So speed is equal to the distance traveled divided by the time taken. Now, the symbol for speed here is we use the letter V. The symbol for distance is S, and again the time taken is T. Remember, this is just a foundation. I know you have learned about this before. We are trying to remind ourselves so that you can use the same information next week. Now, in this case here, V again is equal to using the symbol S divided by letter T. Now, the SI unit of this SI unit is equal to meters per second. Why? Because the distance we measure it in meters, and the time we use the second. So the unit, the SI unit is meters per second. M/S. M/S. Now, let's do some practical examples on this one before we move on. Next one we have is, remember again, this is a scalar quantity. It's not a vector. Speed is a scalar quantity. Example, a car travels a distance of 75 kilometers in 2 hours at a uniform speed. Now, express its speed in kilometers per hour and in meters per second. Kilometers per hour and meters per second. So here is the solution of 2 answers. You need kilometers per hour and also meters per second. The distance is 75. The time is 2 hours, but we don't know the speed. So substituting that, number 1, 75 divided by 2, the answer I get is 37.5 kilometers per hour. 37.5 kilometers per hour. In kilometers per hour. Now, in meters per second, we know that 1,000 meters is equal to 1 kilometer, and 1 hour is equal to 60 multiplied by 60 seconds, 3,600 seconds. So when you substitute that again, 75 kilometers multiplied by 1,000 meters divided by 2 times 60 times 60. Why 2? Because it's 2 hours. Then you multiply and divide that 10.4 meters per second squared. 10.4 meters per second squared. Next slide we have is as follows. A train is running at a speed of 60 kilometers per hour. How long will it take to cover a distance of 240 kilometers? 240 kilometers. So again, here we go. Solution, we have the speed is 60 kilometers, the distance is 240. What we don't know is the time. But we know that speed is equal to distance divided by time. Substitute the values. Time is equal to the distance divided by the speed. And then when you substitute that 240 divided by 60, you get kilometers times kilometers, and then you get the answer is 4 hours. So it takes about 4 hours for this train moving at a speed of 60 kilometers to cover a distance of 240. It's a very slow train. Okay. Next one we have is next question, velocity. Velocity can be described as velocity can be described as displacement divided by time taken. Displacement divided by the time taken. And again, like speed, because displacement you measure it, the unit for displacement is meters, the unit for time is in seconds. So again, the unit for velocity is meters per second. Again, this is just a background information of what we have learned before. Meters per second. For example, now we use again velocity with acceleration. Acceleration is the change in velocity in unit time, or the rate of change of velocity, the rate of change of velocity. We can describe it as follows. Acceleration is change in velocity divided by time taken again. We have done this before. A equals to V minus U divided by T. And then where A stands for acceleration, and then V for final velocity, U for initial velocity, and again T describes the time it takes, the time taken. Now, the unit for acceleration, like what we learned before the COVID break, the unit again is meters per second squared. Meters per second squared. Next one, we have the following example. The velocity of an object changes from 6 meters per second to 18 meters per second in 6 seconds. What is its acceleration? What is its acceleration? Again, solution here, we know U is 6, V is 18, the time is 6, but we don't know the acceleration. So A equals to V minus U divided by T, which is equals to T minus 6 divided by 6. Substitute that, you get 12 divided by 6. The acceleration is 2 meters per second squared. 2 meters per second squared. Okay. Another example is, but before we do that, I want you to go back to the comment section. Always remember, when you give the exercise answers, describe your name, your room, and your class number. Now, for these answers, make sure you write your answers in the chat room there, or the comment section. And each question will have either 1 minute or 2 minutes. You'll see a clock like this on that, this clock over here, moving some questions, question number 1 to question number 5. Each question takes about only 1 minute. But question number 6 to question number 15, it's about 2 minutes. So it's not a difficult thing to do. 1 to 5 is quite easy. Okay, good. So here we go. Question number 1, practical exercise number 1. Which of the quantities below represents a velocity? Which of the quantities below represents velocity? A, 12 meters per second is. B, 14 meters per second. 14 kilometers per hour. C, 2 meters per second. And D, 15 kilometers per minute. And the timer begins now. Shalisa 5 from 4 says C. 5 from 2, number 22, C. 5 from 3, number 31, C. C, 2 meters per second. Remember this. Remember this. All your answers are C, C, C. I want you to remember this, that velocity is a vector. Velocity is a vector. 5 from 1, number 14, C, 2 meters per second. 5 from 4, number 31, answer is A. Okay, I think you have an idea. 5 from 1, number 14, C. 5 from 1, number 17, C. 5 from 7, number 12, C. 5 from 1, number 2, A. 5 from 7, number 6, A. 5 from 4, number 11, A. Okay, let's confirm your answers. Okay, say A. The correct answer is A. It's 12 meters per second east. It's not C. I'll explain why. It's B. 14 kilometers is not the answer. It's not D, and it's not C. I can see so many C questions there. Yeah? The correct answer is A. Why? Because it's a direction. Velocity goes hand in hand with direction. See, 12 meters per second, 12 meters, 2 meters per second. This one can be speed. Remember, the question is, what is the velocity? So why is that so? Because, again, let me explain this one. Because velocity is a vector quantity. And being a vector, it describes two things. One, magnitude, and also gives you direction. Magnitude and direction. So the correct answer is not C. The correct answer is A. Why? Because you have the magnitude, 12 meters per second, and also you have the direction. Gives you this. So this is the most suitable answer. The most suitable answer. Question number 2. Question number 2, again, is an easy question. Very easy question. Distance is a blank as it does not give direction. A, speed. B, scalar. C, displacement. And D, 42. And the timer begins now. 1 minute. Your answers are coming in quick and fast. 5 from 1, number 17 says B, scalar quantity. 5 from 3, 31 says C, displacement. Okay, B, so many of you are saying B. 5 from 3, 28, B. 5 from 3, 45, B. 5 room 3, 31, B. You have about 15 seconds to go. 5 from 1, number 5, B. Okay, 5 from 7, number 35, B, correct. Here we go, and the time is up. Let's confirm the answer. Distance is what? Distance is not speed. Distance is a scalar quantity. Why? Because it gives you only the direction. The correct answer is B. Not A, not C, and not D. The correct answer is B, scalar quantity. Okay, question number 3. Number 3. A measure of how fast an object moves is referred to as the A, speed, B, velocity, C, displacement, D, acceleration. And the timer begins now. 1 minute. My time is okay, your answers are coming quick and fast. 5 from 4, number 29 says A, speed. A picture 5 from 5, 47A. 5 from 5, number 25A. 5 from 3, number 36B. 5 room 7, number 33. What's your answer again? F? No, it's not. 5 from 2, number 34. A. 5 from 5, number 20. A. 5 from 7, number 6. A. 5 from 2, number 26. A. 5 from 7, number 16. A. I mean, this is easy. The correct answer, time is up. The correct answer should be speed. It's not velocity, it's not acceleration, it's not displacement. The correct answer is speed. Next one, question number 4. Number 4. Blank is a measure of application reference to the origin. A. Scalar. B. Position. C. Vector. D. Magnitude. And the timer begins now. 5 from 546 says B, position. 5 from 3, number 12, B says position. 5 from 4, number 25, B, that is okay. That is quick and fast. 5 room 2, number 13, B, good job. 5 room 3, number 41, B, perfect. 5 from 1, number 35, B. 5 from 2, number 27, B. 5 from 1, number 14, B. 5 from 3, number 9, B. 5 from 1, number 17, B. 5 seconds remaining. 5 from 6, number 42, B. And 5 room 2, number 11, B. Time is up. Let's check. The correct answer should be position. Yes. Position is a measure of a location with reference to origin. It's not a scalar. Scalar, we say it only gives you only one thing. That gives you only the magnitude. Vector gives you magnitude and direction. It's not the magnitude means size. So the correct answer is B, position. Position. Good job. I can see your answers, all of you. Good job. Next one. Question number 5, the last question when it comes to sentence questions. What is described as the rate of change in velocity per unit time? A. Locomotion. B. Motion. C. Vector. D. Acceleration. And the timer begins now. 1 minute. 5, room 5, number 33, your answer is D. 5, room 3, number 24, A. 5 room 1, 29, A. Good job. 25 room 4, 29, D. D. Oh, I can see so many D's here. 5 room 4, number 41, D. A few times. Meow. 5 room 6, 42, D. 5 room 2, number 26, D. You have about 20 seconds remaining. 5 room 5, number 34, D. 5 room 7, number 16, D. Okay, this one is easy. 5 room 3, number 14, D. 5 room 7, number 48, D. Good job. Time is up. So let's check. It's not locomotion. Locomotion means movement. It's not motion. Motion is movement that changes position. Its correct answer is acceleration. D. It's not vector. The correct answer is acceleration. D. Now, for the next 10 questions, these are calculations. 2 minutes each. 2 minutes each. I want you to have maybe a piece of pen and a paper. They're not difficult questions, for sure. These are very easy, basic science questions. Very easy. Because I don't want to give you homework. No homework. Just basic questions. Okay. I hope everyone is ready for this. Question number 1. Number 6, or number 7. An object moves 9 kilometers north. Then takes a right turn and moves 15 kilometers east. Find its displacement. And the timer begins now. 2 minutes. 2 minutes. Five, row 3, number 24D. That was so quick. 5, row 4, number 1D. Good job. 5 room 7 number 35, you see D. 5 room 2, 5 room 4 number 2, D, correct. Still have rest, still have about a minute, about 1 minute and 5 seconds. 5 room 5 number 21, D. 5 room 7 number 20, D. Any students from room 8 present? None, not seen any roommate. 5 room 4 number 15, D. 5 from 7, number 58, D. 5 from 6, number 42, D. 5 room 5, number 47, D. Okay, good job. Keep it up. Well done. Okay. 5 from 8. Oh, 5 room 8, number 50, D. Okay. 5 from 7, number 12, D. How about 20 seconds? 20 seconds remaining. 5 room 4, number 5 room 4, number 7, D. 5 room 5, 20, number 20, D. Okay, time is up. Okay, so let's check the answer. It's not 19. All your answers are correct. The correct answer is D. 17.49. 17.49. And how did you get this one? Again, let me show you the steps. It's a Pythagorean theory. So an object moves 9 kilometers north, then it takes a right turn and goes 15 kilometers. So what we need is this displacement. This point here. Displacement is that point here. Displacement. Now, if that is the displacement, it looks like this. Pythagorean theory, we know that c squared is equal to a squared plus b squared. Substitute that, you get 9 squared plus 15 squared. 9 squared is 81 plus 225. When you total up, it comes to 306. Then the square root of 306, you get is 17.49. Because your answers are, all of you're correct. D. Next one. Next question, we have question number 7. A car took 20 minutes to travel 10 kilometers. What was its speed in meters per second? And the timer begins now. 2 minutes. Okay. 5 room 3 says D, 7.21. In meters per second. Meters per second. Not kilometers per hour, meters per second. Okay, you say 5 room 2, number 38, 8.33. Okay, good job. 5 room 8, number 16A, good job. 5 room 5, number 21A, perfect. And here we go, 5 room 1, number 17A. Then 5 room 3, number 31A. 5 room 2, number 13A. 5 room 4, number 31A. 5 room 4, number 41A. 5 room 1, number 31A. You still have about 15 seconds. 15 seconds. Then you try and move on. We have about 20 minutes. Okay. And time is up. Okay. The time is up. So let's confirm the answers. 7.21B. Not at all. Let's see. Okay, 8, right? the correct answer is A, 8.33. 8.33. It's not B, it's not C. The correct answer should be A, 8.23. Now, how did we calculate this one? These are the steps. A car took 20 minutes to travel 10 kilometers. What was its speed in meters per second? Time is 20 minutes. Distance is 10. We don't know the speed. Again, 1 minute is equals to 60 seconds. When you substitute that, 20 minutes is 20 times 60. When you substitute that is 1,200 when you multiply. And then 1 kilometer is 1,000 meters. 10 kilometers is 10 times 1,000. You get 10,000 meters. Then speed is equals to distance divided by time. And then when you substitute these values, 10,000, when you divide by 1,200, the correct answer is 8.33 meters per second. 8.33 meters per second. Next question is question 8. How long in minutes would it take a car to travel 20 kilometers if its average speed is 60 kilometers per hour? And the timer begins now. Timer begins. 2 minutes. 2 minutes. Five from 5, number 47A, 19 minutes. 5 from 6, number 42A, 19 minutes. 5 from 3, number 37A. Okay. Check again your answers. 5 from 4, number 29A, 19 minutes. 5 from 6, number 32, A. 5 from 7, number 15A. 5 from 2, number 27A. You have about 30 seconds, almost a minute. 5 seconds there. Okay, there you go. 5 from 1, number 26, you say the answer is B. Okay. 5 from 2, number 16, your answer is B. 5 from 1, number 3, B. 5 from 8, number 50, A. 5 from 1, number 25, answer B. 5 from 7, number 35, B. 5 from 3, to Chanok, 53. Sorry, answer is B. Only polar. 5 from 3, number 36, B. 5 from 1, number 33, B. 5 from 4, number 11, B. 5 from time is up. 5 from 3, number 9, B. Okay, let's check the correct answer. The correct answer again is B. 20 minutes. It's not D, it's not C, and it's not A. The correct answer is 20 minutes. Now, how did we get these 20 minutes? How did we find this answer? Now, how long in minutes would it take a car to travel 20 kilometers if its average speed is 60 kilometers per hour? Now, let's write the values that we know. The time, we don't know. The distance is 20 kilometers. The speed is 60 kilometers. Now, if you substitute this value, we know that speed is equal to distance divided by the time. The question is, what is the time? Time is equal again to the distance here divided by the speed. When you substitute that, you get 20 kilometers divided by 60 kilometers. Then the answer you get, when you, kilometers will cut kilometers, then you get 1/3 of an hour. But the question is, it's not in hours. The question is, how long in minutes? How long in minutes? Now, we know that 1 hour is equal to 60 minutes. So 1/3 of an hour is equal to how many minutes? 1/3 times 60 is 20 minutes. The correct answer was B. Okay, next question. Number 9. Question number 9. A car travels at 45 kilometers per hour for 4 hours. How far has it traveled in meters? In meters. And the timer begins now. 2 minutes to do that. 2 minutes. Two minutes. Okay. 5, room 1, number 9, C. 180,000 meters. 5, room 5, number 46, C. Okay. 5, room 3, number 21, C. 5, room 1, number 33, C. 5, room 7, number 6, C. 5, room 3, number 1, C. You still have about 1 more minute. 5, room 5, 43, C. 5, room 3, C. 5, room 2, number 6, C. Very good. I think your answers are all correct. Let me skip this one because of time. We don't have much time remaining. So, okay, the correct answer here is CY. Time is 4 hours, the distance, we know, and then speed is 45 kilometers. Divide that, and then you get speed is equals to distance. No, the distance is equals to speed divided by multiplied by time, which is 45 times 4. When you do that, you get 180 kilometers. Now, the question is, we want the answer in meters. In meters. So we know that 1 meter is equals to 1,000. Sorry, this one is 1 kilometer. I'm sorry. This is 1 kilometer, not 1 meter. This should be 1 kilometer is equals to 1,000 meter. Then 180 kilometers is equals to how much? So 180 times 1,000 is 180,000. So this is 1 km, not 1 meter. Correction. Next question, as we almost finishing, question number 10. A biker is traveling at 120 kilometers per hour. He travels for 45 minutes. How far has he gone? The timer begins now. 2 minutes. 2 minutes. Okay, that's quick. 5 from 1, number 10, D, 90 kilometers. 5 from 2, number 27, D, 90 kilometers. 5 from 4, number 31, D. 5, room 4, number 41, D. 5 from 7, number 35, D. 5, room 3, number 34, D. 5 from 7, D. 5, room 1, number 3, D. I think your answers are correct, all of them. So, how the correct answer is not B, is not A, is not C. The correct answer should be D. 90 kilometers. And this is how you get these answers. And quick because of time. So a biker is traveling at 120 kilometers per hour. He travels for 45 minutes. How far has he gone? So the time is 45 minutes. 45 minutes is about 3.25 of an hour. 3 over 4 is about 0.7 of an hour. The speed is 120 kilometers per hour. What you don't know is the distance. How far has he gone? That means what you're looking for is the distance. So when you substitute that, speed is equals to distance over time. So the distance is equals to the speed multiplied by the time. 120 times 0.5, you get that one. When you cut that, then you're left in kilometers, you get 90 kilometers. 90 kilometers. Next question, we have question number 11, this acceleration. The velocity of an object changes from 18 meters per second to 30 meters per second in 4 seconds. What is its acceleration? The timer begins now. 2 minutes. 2 minutes. Okay. This is acceleration. What is its acceleration? Okay. 5 from 3, number 31A, 3 meters per second square. Okay. 5 from 4, 23A. Okay, A and B, I need one answer. I just need one answer. 5 from 5, number 43A, 5 from 3, number 28A, good job. 5 from 1, number 17B, 3 meters per second. Okay, yeah. A and B, the answers are the same. Okay, I get a point now, yes. The two answers are correct. The two answers are correct. It's a mistake on your part. Sorry for that. A and B, the answers are correct. So if your answer is A and your answer is or B, you can be sure the two answers are the same. So because of time again, let's check. The correct answer should be A or B. The correct, and it's not B and it's not C. It's on either A or B. 3 meters per second square. That is the acceleration. How did we get that? As follows. The velocity of an object changes from 18 to 30 in 4 seconds. What is its acceleration? Okay, 18 is u. The final velocity is 30. The time is 4. The acceleration we don't know. A equals to b minus u divided by t, which is equals to 30 minus 18 divided by 4. Substitute that 12 meters divided by 4. The correct answer is 3 meters per second square. 3 meters per second square. We have about 5 minutes remaining, 4 questions to do. Question number 12. A train is accelerating at a rate of 2 meters per second square. If its initial velocity is 20 meters per second, what is its velocity after 30 seconds? The timer begins now. 1 minute, not 2, 1 minute. Answer is C. That is 5 from 2, number 22, C, 60 meters per second. 5 from 2, number 27, you say C, 60 meters per second. 5 from 1, number 17, B. 5 from 7, number 18, C. I'm getting different answers here. 5 from 3, number 1, C. 5 from 4, number 15, C. 5 from 3, number 41, C. 5 from 3, number 21, C, 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 C. Okay. Okay, because of time, I'm trying to rush. Time. I'll give you 5 seconds. Let's confirm. Your answers, let's say, is C. Why are your answers C? A. The correct answer should be actually B, not C. C is not 60. It's not 60. Oops. Yes, it's not 60 and it's not 40. The reason is this. Let me explain. A train is accelerating. The acceleration is 2. A is 2. We know A. Acceleration is 2. U is 20. At an initial velocity, not final. So initial is 20. Time is 30, but we don't know the final velocity. But we know that V equals to V minus U divided by T is equals to A. So when you substitute that, 2 is equals to V minus 20 divided by 30. So when you cut that, cross multiply on both sides, 2 times 30, you get 60, V minus 20. So 60 plus 20 is equals to V, and then when you substitute that, V is equals to 80. 80. It's not 60, it's 80. So check on that. Yeah, but I can see B from 5 from 4, 5 from 4, 5 from 7. Next question, question 2 more questions, then we finish. An object decelerates. Check on this. Decelerates from 15 meters per second. 15 meters per second is at a rate of 1 meters per second square. What is the time taken to come to rest? Come to rest. And the timer begins now. 1 minute. A answer is 12 seconds, B 0, C 15 seconds, and D 14 seconds. 1 minute. Five from 1, number 17, C, 15 seconds. 5 from 8, number 16, C, 5 room 1, number 10, C. 5 room 5, number 20, C. 5 room 3, number 28, C. 5 room 3, number 1, C. 5 room 4, number 2, C. Good job. Very good job. Let's check the answer because of time. Okay, it's not 14, it's not 0. The correct answer is 6, 15 seconds. And this is why. Because it's deceleration now. When it's deceleration, means that it's a negative acceleration. Every time you see deceleration, you put a negative. It's negative acceleration. So there we go. A equals to V minus U divided by T. When you substitute that, 0 minus 15 divided by T, again, it's negative because it's deceleration. You are slowing down. You're slowing down. So when you substitute that and cut, you get the answer is 15 seconds. 15 seconds. 2 more, then we call it a day. Question 14. Question 14. A truck moves from 20 meters per second to 10 meters per second in 10 seconds. What is its acceleration? The timer begins now. 1 minute. 1 minute. It's a very easy question. Okay. 5 from 2 is number 22. Answer is D. D. 5 from 3, number 21. B. 5 from 2, number 1. B. 1 meters per second. 5 from 4, number 2. D. Minus 1 meters per second. 5 from 2, number 2. D. Minus 1 meters per second. 5 from 5, number 45. B. 1 meters per second. So your answers are to either 1 or negative 1. Which is which? A, B, A, B, D. We have D minus 1 meters per second. Okay, because of time, I have 1 minute remaining. All right, the correct answer should be D actually. It's a negative because it's the following. Right? It's a deceleration. So A we don't know. U is 20, V is 10, time is 10. And then you substitute that. Sorry, yeah. A equals to B minus U divided by T, 10 minus 20. Sorry for that. And then when you cut and cut, minus 10 divided by 10, it's a negative answer. So this is what you are calling deceleration. Negative acceleration is deceleration. So it's not 1, it's minus 1. It's decelerated. Deceleration is when you slow down. Acceleration is a positive acceleration. You have a positive number. Last question, number 15, we have the following. Traveling at an acceleration of 2 meters per second squared, the velocity of a bus changes from 10 meters per second to 24 meters per second. For how long does it travel? The timer begins now. The last question. Last question. Last question. D. Okay. Okay. 5 from 1, number 10. E. There's no E. Okay, E. Some of you say E, yeah? Should be A, B, C, and D. Correct. E. 7 seconds. There's no C. You have E. Mistake on my part. 5 room 4, number 25. E. 5 room 3, number 21. Answer is E. Because of time, it's not B, it's not D. The correct answer is should be just E, and it's not A. Why is that so? Because of the following. 1, 2, go to the last question. Again, substitute that. But at your free time, you can go through this, and then you find the answer is equal to 7 seconds. 7 seconds. Now, that was a quick lesson, a very quick lesson, which is setting a foundation for what we are going to study next time. So, thank you very much for your time. Have a wonderful time and also continue to keep safe and to protect yourself from COVID. Thank you.